Hey everybody, welcome to a new video. This is the Lone Tinkerer channel. What we have here is a Heathkit RF signal generator, model IG 102, that I bought on Mercari. Got a pretty good deal on it. I think it was like $45, $50 including shipping. So let's take a look at it and see what we got going on here. Alright, so I'm going to pretend like I didn't already take this apart and act surprised when I look inside to see what's here. So I took the case off. Here's what it looks like inside. So obviously this is not supposed to be like this. I guess I'm not making it any better by bouncing this all over. So I need to figure out what's going on with this. The shipper did a pretty, the guy who sold it did a pretty poor job packaging it. When I opened it up, the back case was halfway off, and there were these two screws hold the back on, but all these screws were laying inside the box. So that's not too cool. I don't know if they're all, looks like I might be missing one nut, and that might be about it. Unless it's inside the case here someplace, I'll have to see if that's the case or not. So I know that this, I did a little bit of research already, and I know this goes here like this. There's 4 screws that hold it on. This is all bent up. This is supposed to go down, so I'm going to have to unbend that. And then these 2 wires connect over here somewhere, and I'm not exactly sure where. And this little what do you call it, terminal strip is bent as well. It's bent in, it should be bent out. I don't know if that shows up on the camera or not. So what this does, what this unit does is you can use it to send radio signals, so you can test AM receivers. So RF is radio frequencies, so you can send radio frequencies with it. So you got your power switch. And I'm going to be honest with you, I don't know what some of this stuff does, but basically what you can do is, this is kilocycles here, so you can choose A, B, C, D, E, F. So if you want to do 100 kilocycles, that's 100,000 cycles per second. And then you've got megacycles, 3.1 megacycles, 10, 32 megacycles, etc. And what this, so let's see here. So like if I was on the A range, you can see there's like ACE is here. So that would tell me that my scale, so like this right here would be about 310 cycles, or 320 cycles. And then it goes, it'll go all the way up to there's your 320 is right there. 3.2 would be 320 kilocycles for A, and then you get the same thing for A and F. So the unit has a dent in it. This was in the picture, so that did not happen during shipping, which is good. The case itself doesn't seem to have any problems. So part of the work that I'm going to have to do here, well, this broke off, you can see that. So this capacitor has two capacitors in it, and I'm going to change this one out for sure. And I'll have to look and see if there's any others in here that I want to change out. There's a couple here. There's not really a lot of capacitors here. In the ceramics I won't do anything with. And yeah, so that's kind of my starting point. I did find a kit online for new power cord and new capacitors, but I don't know if it included this electrolytic or not, so I will have to look and see if I can get that one. So that's what we're up against. I have a schematic for it, so that will help me to figure out where these wires terminate in here, and it'll give me a good jump on things. All right, so after doing a little bit of analysis here, I was looking at this terminal strip, and I can see that, hopefully you can see this in the camera, this is broken in half. So this is a 5-position terminal strip. It's also very loose. The nut's almost coming off. So I'll either have to buy one of these, or I have another phone a friend who probably has a metric S load of these, and he'll probably give me one if I ask for it. All right, I would show you a little bit of soldering in here, but it's very, very hard to see. I don't know if you can even see right there is my work. You can just, that's kind of what it looks like. The only thing I have left to hook up now is the power, and that's just these 2 wires here that I stripped off. Okay, I'm going to shift gears a little bit here. I need to make a change to how I'm doing this. So you recall I've soldered in these 2 kind of brown looking capacitors. Those are ones I actually want to get rid of because they show up in here as, this is a 0.02 that goes to ground. This is another 0.02 that goes to ground. And those are the ones that can, if they fail, they can put voltage on the chassis directly, and we don't want that. So what I'm doing instead is I redrew this so we can kind of take a look at it together. So I've got the polarized plug coming in. I'm going to have my hot go to a fuse, to the power switch, and then to the black line, and then this other black line goes back to the neutral, back to that's rest your power. So I'm going to remove those 2 capacitors and continue with the wiring. I guess I could cut this too, but I kind of don't want to leave it as a mess. I'd rather have it be pretty good. There we go. Guess I kind of ruined these, but they're pretty cheap, so I'm not super upset about it. And I also have I don't have a fuse holder, but I do have the electrolytics that I needed, so I can put those in today too, so that'll be good. One thing I wanted to do is I want to buzz out these transformer leads, because in my original drawing I didn't have these 2 connected to anything. I thought they were unused, but you know, they're connected over here someplace. I think they're connected here, but yeah, I think they go right here. But I need to verify that once more. But I want to figure out what's going on with these windings. I'm sure it worked the way it was, but I guess I want to know. So I have right here, this is black, kind of with a yellow stripe, and this is black with a yellow stripe too. I think that's yellow. It's really, really hard to see. And then these 2, well, yeah, this is black with the yellow stripe, and the other one looks like it's black with a green stripe. But I'm imagining that these 2 sets of windings are perhaps connected together in series, but I'm going to check that out and see. Okay, so I took these, I unsoldered all these windings because I was curious about the configuration, and I'm glad I did, because the way it was wired wasn't going to work. So I don't know if this unit ever worked. I have no idea what other kind of things I'm going to find, because it was wired wrong. It looks to me like the way it was wired, it probably would have just blown a fuse or blown your circuit breaker for your power. So this is how this was wired. This wouldn't do anything. So basically you had this going to power, and this going to power through your switch. So this would have been your outlet, like this. So this, what should have been done is this should have been wired in parallel. So I came up with, I'll just show you how this should have been wired this way, and I'll explain why. So I should have had red, black, and black, green. I'll just put them next to each other for, whoops, this should be black, white. So you got one winding here, and then your other winding here. So these would be connected, and these would go to power, and these would be connected. So your outlet would kind of look like this. Sorry, this is so sloppy. I'm just trying to do it fast. And then this side would be black, green. So your red, black goes to your black, green. And your, let's see, your black, green. Let's see, black, green. Oh, did I do this wrong? So yeah, red, black goes to black, white, and then black, green goes to black, yellow. All right, and then that goes through your switch up there. So sorry, this is so messy. So these both give you 120 volts out, and from my digging, this provides double the amount of power out to your transformer. So in this other picture, let's see, they don't separate it. So they don't show both windings in here, because the transformer, from my searching, this transformer is not the transformer that this should have come with. It should have come with just two sets of windings. Black, the primary was two blacks, like shown here, and then you had two reds and two yellows. In my transformer, like I showed you, the wire colors are all different. So what I'm going to do, I guess one thing I could try is only to hook up one set of transformers and see if it still works, because it could be that it doesn't even really need all this power to run. I'll have to think about that a little bit if I want to. I guess if it doesn't work, Well, I guess, yeah, I'll just hook them both up because the transformer shouldn't get hot probably if I connect it that way. It should work. So I got enough parts. I'm going to keep going here a little bit. I'm going to wire this kind of up the way it's supposed to go. I don't have a fuse holder yet, and I don't have a fuse, so that's going to keep me from moving forward part of the way. But there are some things I can get done, so I'm going to get set up to do that. Okay, I'm going to switch gears here a little bit. I'm just going to wait on that transformer wiring, at least that part of it. But I can wire up this. These are the two reds on that I showed you in that image. So one of the reds goes to the anode of the diode. So one of them goes here, and the other one goes to what becomes the B plus, which is 150 volt. Well, the voltage is 150 volts. I guess I can show you that here. So this is a circuit right here. So one of the reds is going to go to this side of this diode, and the other red is going to go to, they show it going to ground. I don't know if that should go to ground or not, now that I look at it. Actually, it shouldn't matter because it's going through, it's got these capacitors here that are going to pick it up, so I think that'll be fine. So you're going to end up with a halfway rectifier, so you're going to end up with something like this. And these two caps are going to clean that up so that you get something a little bit closer to, you know, to be something like this. And this is going to be, so this is going to be your DC. This is going to be about, over here it's going to be like 130 volts. Across here, so I think that's fine, that this can go to ground. I won't change that. All right, so I have my capacitors, and this is calling for 20 microfarad. Okay, so I have most of the parts I need now, I think, for the signal generator. So I'm going to start getting this guy, get my parts laid out, get my schematics laid out again. We could discuss those. And I got another change on here I wanted to make that I don't think I've mentioned yet, so stay tuned.
Letting it bake for a while, and then setting the cutoff where it should be set. Oh, it's waking up a little bit, but this is still the result. Would that produce a picture? Yes.
I don't know if this iron will get hot enough to melt the solder. We'll see.
We will get to this at some
Looks like it's maybe doing it.
I'm going to mark it this week. So I can process it in the which is burn stamp. Run it down and get the controls back. Hidden mother special here. Hidden mother special ladder. 13M15.
Okay. So this is the polarized thick one here. So that's going to go through the fuse.
Low cost oscilloscope, and there's a whole web page devoted to this thing. And it's a 1-inch CRT. And oscillograph. And I would really like to see this work. I don't know really what you could do with it.
So I kind of screwed up here a little bit. I should have left the one line and not cut it off, but too late now. So I'm going to have to solder these two back together, but I guess it might be okay because I can do a turn here. I'll solder this like this, and then it'll be the right length, and I can just put shrink on this. I'm listening to Shingo 66, I think it is, in the background.
Fix the
And you really need to, if you like fixing stuff like this, old tube stuff, be sure to check him out. He's just a genius. He's just a freaking genius.
Yeah, I'll take the.
I'm going to tape these together. That's going to make it a little bit easier.
The feet.
I just wanted to hold these together while I solder them. That's good. I think that's going to be pretty good. I know I should use a heat gun, but it's noisy. And I'm too lazy to go get it. There we go. Okay, so when I'm all done, I can mount this in the panel, but for now, it's gonna just make things a little bit easier to work without having it in the way. So the next thing I want to do, I'm going to mark the end. I apologize for marking it white, but that's what I have for colors because I want to keep track of. So this is my white coming in, my white going out, and this is my white on the other end. So this is my hot. So that will go through my switch. At this point, I think maybe it doesn't really matter. Yeah, it does matter. I need to go through the switch side of the power switch. There we go. All right, so here's a little bit of an update. I decided to take the transformer and the terminal strip out of the chassis because these two of these coil wires were cut so short I couldn't make any kind of connection with them to this terminal strip. So I decided to just go ahead and unsolder everything and just kind of start over again. So I've got this. I need to put a little bit more solder on that maybe, but then I just need to locate the rest of this stuff. And I'll show you when I'm kind of soldering it back up again a little bit more what I ended up with for my terminal strip terminations, if anybody cares about that. Okay, so this is supposed to go in here like that, otherwise these are going to be too short to get to the the filter caps. So I still need to kind of keep everything together like this. But at least I got it leads long enough I can do a little bit of something with them if I want. So now I'll just set this in here and figure out my two new wires here. My terminal strip. It kind of sucks because the wires are just barely too short. But now I'm going to have really long wires in here, which I guess, you know, you're supposed to keep stuff short for power, to keep the noise down. But this is, since this stuff is running at RF frequencies, I think it's going to be all right. I don't think I'm going to have a lot of problems with it, with any kind of noise and stuff. So we'll call that good. So for this one power wire, this is the one that's the neutral. The wires were just too thick. I couldn't fit them through the hole on the terminal strip. There's just too much wire diameter. So I ended up, I'm just going to solder those. I solder them together and I'm going to put some heat shrink over them. And that should be good enough. It's just, I mean, it's nice to have everything clean on a terminal strip, but at some point you have to give up a little bit and just get it done. Otherwise you're wasting too much time trying to make things look good. This is the side of the heater, the transformer lead for the heater that goes to ground. So I had kind of figured that out earlier, that that's where that went, but I was having trouble finding it back again in my notes. But yeah, it just goes to this middle terminal and then it gets screwed down to ground. So I'm all done with this transformer wiring finally. I guess I could loosely, I gotta tie this down anyway because of the heater, but the ground for the heater, but I could probably leave this a little bit loose if I wanted to. I'm going to measure this rectifier diode and make sure it's good. Nothing that way, and I should get 0.7 this way. Actually, I'm going to use my, yeah, so it's open that way. This meter shows a diode tester, but it's not really doing what a diode tester should do. For a diode tester, you should see the voltage that's turned on. So I'm going to try my other one. So in the circuit the diode is, you know, it's in this circuit. It should identify a diode, but I'm not 100% sure it will. So let's try this again. All right, so it does show a diode here. So it does, and it, yeah, so it's a diode and it's good. So that's, and it's measuring the other things that are in the circuit too, I guess. So my next thing I want to do is get the capacitors, the new capacitors put in. So another shipping casualty was these connections. These are the red connections that power the rest of the box. So I need to connect one to the bottom of one of the 20 microfarad capacitors, and the other one just gets connected to the anode of the right here. So one of my wires gets connected here for the red, and the other one I can connect it to the ground on the 20 microfarad capacitor, and I'll show you that here. I don't really need to draw this, but I'm going to draw it real quick anyway. So I have another terminal strip here with 4 positions. And so on the first strip I have one of my capacitors coming out, and that's going to be the plus. And then I have the other capacitor coming out on this one, so that's going to be like this, and that's the positive side of that one. And then I have the diode here. And that goes over to here. And then these both go back through the board and they go to ground. And then I have a resistor also going across from here and that goes over to here. So I'm not changing any of these things. I'm just changing this capacitor. go. All right, so I need to make something like that. Shouldn't be too bad. Cut that one a little bit too short. I probably should have left these longer because it's better not to get so much heat on them, on the leads. These are rated for fairly high temperatures, but all the same, it's probably not a great idea. Okay, I'm hooking up my capacitor that I just soldered up. I think I'm in good shape here. Waiting for the soldering iron to warm up a little bit, and then I can put these down on their terminals. Yeah, that's the first one. I think I might need to put a little bit more solder on that. I don't have a hole to put it through, but I can solder it directly to the top of the terminal strip. Okay, now this solders to the ground right here. This wire I'm using is some extra cutoffs that I got from my work. They use really good wire, really good quality wire. So this is stranded wire, 10 stranded wire, 20 gauge. And I just got you know, bundles of it that was all cutoffs, and it was all like at least 3 feet long. So for stuff like this, it's perfect because you got as much of it as you could ever use. All right, so as you can see, I've taken out the 2 tubes, and I've got everything else, I think, ready to go, and I'm ready to plug this in and see if I'm getting my DC voltages, the B pluses that I expect. So I got my my voltmeter hooked up here, and I'm going to go across, let's see, on one of these I'll get 130, and on one I'll get 150, I think. So I'm going to connect here, and where's my other side? I guess ground, so I can connect to ground. So get my power cord here, and I'd have a fuse in here. There's a voltmeter. Let's hopefully this works. Let's see what we get. I don't smell any smoke, but we're not getting any voltage, so see if I blew my fuse already. I heard a noise. Oh, you know what? I gotta turn it on. Let's do that. Let's try that out. All right. So here's the power switch. No smoke. No voltage. All right, now we can check the fuse. Okay, I unplugged it. And it looks like my fuse might have blown. Yeah, I think my fuse blew. Okay, I think I've got everything hooked up now as much as I can without actually plugging it in. So my next step is going to be to unplug it. Well, it's not plugged in. To unplug all the tubes, which there's 2. So all the tubes I gotta remove. And I'm gonna mark these so I remember where they go. So this is gonna be 1. This is gonna be 2. And I should be able to guess I didn't notice this switch is all bent. The back of it is all bent. So that's on, that's off. So what I'll do, actually I have a variac. I'm gonna get my variac and hook that up. All right, I've got everything connected now. So what I want to do, I took out all the tubes and I'm gonna hook up a voltmeter here and measure some voltages. Hopefully I've got everything right. And if this is working, then I should get some good measurements. So what I want to do is I want to see what I get for, I should have a B plus here. So at one of the capacitors I should have 150 volts, and at one of them I should have 130. So I'll pull this back a little bit. Guess I better solder on that capacitor first, huh? I got out of step here. Yeah, my fuse is blown. All right. Guess I should have bought more fuses. I only have 2 of them. I'm back to my handy dandy transformer picture here again. When I hook this up in the unit, it keeps blowing the fuse, so I need to figure out what's going on with it. So one thing in my research, with a transformer like this, you can see, as we talked about, I want to do in parallel connection of these sets of windings. But I do have to do it so that they're in phase with each other. If they're out of phase, so in other words, I have to have my hots on the same pair of wires and my neutrals on the other pair of windings. Otherwise, they're going to be out of phase, and it's going to make it get hot. From what I've read, I haven't messed with these, but the research I did, it says this would get hot, and I think it would blow a fuse if it did that. So what we need to do is wire these so that they're additive, and then we'll get the output voltage we expect, and it'll be stable, and it won't pop circuit breakers. So I did run this with windings individually. So if I ran AC through one winding, I would get secondary voltages that I expected. So like on the yellow, for the heaters, I would get 7 volts with nothing connected to it, 7 volts AC. And the reds, I would get, I think I was getting like 112 or something like that. So individually, each one of these does provide the power that I guess I don't know about the voltage yet. This voltage looked fine. On the reds, it seems low to me. And we'll see what happens with that. But what I'm going to do now is I've got some of the recommendations that I read said what you could do is one of 2 things. You could just use line voltage and hook things up through a fuse, just like for a few seconds, to see if you're getting additive voltage out of your your winding configuration. So if you've got it wound right, you'll get additive voltage. If you don't, you won't get additive voltage. One of the other recommendations was you just put for your mains, your primary windings, you run a very small AC voltage and see what your outputs do, because then with a real small voltage, you can't really hurt anything. So I had in my endless pile of wall warts, I had this AC transmitter, or AC transformer, sorry. And I have no idea what this is for, but it is AC output. I was concerned that it says 9 volts, 120 volts AC to 9 volts AC. I thought, well, maybe this AC is a mistake and it's supposed to be DC. But when I do measure the output, I do indeed get 9 volts AC out of this. So I'm going to cut the end off of this, strip the leads back, and work on some instructions that I downloaded on what I can do to make sure I'm getting these in proper phase. Okay, so the first step of my testing here is I need to make sure that my primary windings are what I expect them to be. And I've done this before, but we'll do it once more for the sake of sanity. So my black yellow and my black white should be one pair. So here's my black yellow and the black white. I should get a resistance, a finite resistance through here. And I'm showing 127 ohms, and I should not have continuity anywhere else. So I'm just checking. So and here's the red one. I should have nothing, and here's the green one. I should have nothing. All right, so that tells me that is the winding. That is one winding, is this black yellow, black white pair. So now I'm going to do the same thing with black green and red black. So black green is here. Red black is this one. Okay, that one's 118, and that's a finite resistance. So again, I should have nothing on any of these other windings, and there's nothing there. So only this is the only one where I have anything. So I guess I didn't check the secondaries. I'll check those as well for the main secondaries here. So I'm getting nothing there, and we'll do that. We'll just do that with all of these, just for sanity check. Because if something was shorted inside, that would definitely cause this to not work right either. Okay, so these are all isolated from each other. All right, so the next, what I need to do, let's see, I did the continuity testing. So now I'm going to do a low voltage AC test with a small AC source, and I'm going to connect we'll start with black white, black yellow. That's what the instructions said. So what I did, all I did here is I had given all my information to Perplexity AI. I use AI, I like to use AI for stuff, and I told it, these are all my windings, these are the colors, my primaries are these colors, my secondaries are these colors. And I asked it, how would I test this to make sure I'm getting it in phase right? And I said, I would like step-by-step instructions on how to do it. And it gave me step-by-step instructions. So I'm just going to go through my instructions, and hopefully it will be accurate, and I will get what I expect. All right, so I was getting a little bit confused with the setup. So I drew it out with the test setup that they gave me. So this is my initial test setup. I've connected my AC power to these two windings, which is this primary, and I also tied this winding back over to this red black, and I'm measuring the voltage across these two windings, and what they want me to see is that I'm getting near 0 volts here, and if I'm getting double that, then that means they're out of phase. So what I need to do is, since it's out of phase, I need to tie black and green to black and white. So I need to get rid of this. So I'm going to go black, white to black, green. And then I need to measure between black, yellow, and red, black. So black, yellow, and I'm going to get rid of this one. And I'm going to go up to red, black. All right, so I'm going to redo this and as described here, and we'll see what we get. Okay, so I connected these up the new way after they said they should be, that it must be out of phase the way I had it wired. So now I've got it connected the new way that I just showed, and I'm getting 324 millivolts, which is almost nothing. So 3/10 of a volt basically. So that tells me that these are now wired in phase. So when I put this back into the unit, I need to wire it in this method so that I get the proper output voltage. So I need black, green connected to black, white, and I need to have red, black connected to black, white. Actually, no, that's not right. I need black, white connected to black, green, and I need red, black connected to AC. So I got it. All right, so I think I got this hooked up the way it's supposed to be. I'm going to try line voltage now. And I should see, it shouldn't pop the circuit breaker first of all, or pop the fuse, and then I should get voltages out. So let's see, do I got this hooked up right? Let me check things once more here. All right, damn it. Okay, so I went through matching up the phasing on that transformer, and it still blew a fuse every time I tried to use it, and I wasn't getting any kind of output voltage. So I am going to replace that transformer. Okay, so you can see my mess here. All right, here's what I came down to. I don't have it in front of me here, but the transformer that came in this unit, after all the testing and screwing around I did, I figured out that it's bad, which really stinks. But it is what it is. So what I was going to do is I found this transformer that is just a coil, or a filament or heater transformer. So it does 120 in, and then you've got your 6.3 volts out. It looks like you got two sources you can do. So this, I bought this. This was like $15, and I was going to use this. And this is my phone-a-friend Eric had this. This is a transformer for doing tube amplifiers. So this transformer has 12.6 volt output for heaters, and then it's got 125 volt out isolated. So you do mains 120 in, and then you got 125 volts out to run your plate voltages, etc., in your amp, and then you've got 12.6 volts AC for your 12 volt heaters. That's 12AX7 type amplifier. That's what he was using these for, and he bought a handful of these and got a good deal on them. So what I was going to do is use, this has 6 volt. This is a 6 volt heater, which is what I need for my tubes. I was going to use just the AC, the 120 volt to 120 volt of this, and then the 6.3 of this. So I started trying to figure out how to do this, and you can see it just be completely jammed in there. I'd have absolutely no room to do any kind of work. So I spent $15 on this, so that's kind of wasted. I'll have to use it for something else later maybe. And then this one, it just doesn't have the voltages that I need, so I'm not going to use that one. And I went online and I found this is a Hammond transformer. You can see how huge this thing is, but I can make it fit in here, I think. I'll have to very much finagle how to get it in here. But this is about the only one I could find that is going to really do what I want it to do. And I hope it doesn't, I don't get interference with my high voltage or with my high frequency coils here. But this is what I'm going to have to go with, because this kind of a transformer is really hard to find that has 120 volts in and out, and then 6.3 volts of heater. I looked around, and there are lots of variations of things, but to get this exact same thing, you pretty much have to order it. I looked on eBay. I couldn't find anything that was exactly what I needed. And then you run the risk, if you're buying something off eBay, you don't know how old it is, how long it's been used. It might work today, but then maybe the laminations are getting bad in it, and it just won't work for very long. So I ended up with this. This is a huge. This is basically like for doing guitar amplifiers, something of that nature. So I'm gonna spend a little bit of time figuring out where my holes are gonna go, and figuring out how exactly I can mount this. And I might do, I don't know if I need to do some standoffs or something like that, but maybe I'll just I can do like this, and then I've got all my wires in here, and I just start hooking them up where they go. Let's see, like I said, I'm not going to do a terminal strip. I'm going to remove this, and I think I'm just going to direct wire everything. And maybe, I don't know, maybe I'll tuck this back behind here, part of the wires. I'll trim these up a little bit. They're, obviously too long, and I don't need a whole bunch of extra wire laying in here. If I ever happen to find another transformer that's more appropriately sized for this, maybe I would remove this and use it for something that warrants a big, huge transformer like this, because obviously this has way more power capabilities than what this little thing needs. So I'm just kind of stuck right now. I want to get this done, and parts are parts. You can always reuse stuff later if you need to. sure there's a better way to do this, but this is what I came up with. So that's going to be my hole that I'm going to put in the cover right here. And figure out where I'm going to put it. Looks like I could put it about right there, and that would work out pretty good. So there's my fuse holder, and there's that guy. And I'm aiming for this gap right here. That's where I want the hole to be. Okay, so I got the transformer mounted in here. It was a very tight fit. I did plan ahead a little bit on this, and one thing I figured out is that I'm not going to be able to use this hole anymore where the power cord goes through. So I'm going to have to drill another hole. I'll probably drill it into the, I'll show you what I'm talking about here. So if you look at this, you can see this goes on here like this, and the power cable is supposed to come out of here, but the transformer is right in the way. I tried to look at leaving a little bit of space. Sorry, making too much noise. So I started thinking I was maybe going to leave enough space so I could get the cable through here, but there's pretty much no way I could have done it and left any kind of strain relief. The cable would have had to make a 90-degree bend to get in here. So instead, I'm just gonna over here someplace, you know, I'll make the power cable come in here, and then I'll drill a hole in here, and I'll leave a little bit of slack on the power cable so that when it gets taken apart again, whoever, you know, a million years from now or whatever, they can get in here, they can take the back cover off and be able to get in here. And if it might end up desoldering the power cord so that they can work in here, but at least they'll be able to get the back off. All right, so I'm going to start laying out the cables on here. May have to dig up my my wiring diagram for this. It does describe it on the top here, but I might dig it up just to make sure I'm doing it the right way. Okay, here's the wiring diagram for the transformer. These lines are really light on here. I don't know if you can see this or not, but you should be able to read the text. So the primary will use this white and gray as our 115 volt input. And then what you do for the output, the green is going to be the heater. And then this actually puts out 380 volts end-to-end coil, or you center tap it. So if I can do red, well, these are both say red, so I do red and red yellow. I pick two of those, doesn't matter, it looks like, and that will give me 190 volts out. So from the reading that I did, the original circuit, I think it showed, I don't have that sheet in front of me, but I think it showed like 130 or something, 150 I think it showed going into the bridge rectifier on this guy. So I think I should be good with running 190 AC into the bridge rectifier, or not bridge rectifier, but the rectifier. So I'm going to go ahead and start trimming this up and getting wires put where they go. Okay, so here's my schematic. So I'm going to have a red and a red yellow. going over this way. So it maybe would have made sense to flip this the other way, and that way my reds would go directly here, and my greens, I guess my greens, I could maybe, no, I'm not going to do that. So my reds will go up here to these points, and I'll get set up to solder that in. I'm going to clean this up a little bit and make sure I'm soldering it in the right place. All right, so I've got the ground. Actually, so I got one winding. I'm doing this part right here. So I have one side of the red goes to ground, and one side of the heater goes to ground. So I'm just soldering these two together, and I have a ground lug here. So I'm just gonna plug that right into there and be done with it. Hopefully I can get it to go through. There's a hole, nice convenient hole here. If I can get the solder melted, there we go, perfect. Well, actually, let me heat it up just a little bit more. Okay, that should be good. All right, so that takes care of that. Now I've got, let's see here. I got this red wire that's loose. I need to figure out, okay, that goes to one of my capacitors. So one of the reds from my capacitor goes here, which is the anode side of the diode, so it goes right here. So I got, so this, so 1 plus of the 150 goes to this side of the diode, which is already connected, and the red for the other side goes to the anode, so that must go here as well. So I'm going to double check this real quick and make sure I've got things where they're supposed to go, and then get it soldered up. I got this ready to go. I need to take this back apart since I'm redoing these holes. So I don't need this anymore. So power cable will run through here, and then the fuse holder will connect in here like I had it before. So waiting for the soldering iron to warm up, and then we'll get going on this. One thing I decided to change on this, I'll have to look and see, this wire to the power switch looks kind of small to me. I guess it's probably not carrying that many amps, but it seemed kind of small. And this might be 20 gauge, but I think I have, well, I bought this 20 gauge, and that actually looks smaller now that I look at it. So it's maybe a little bit thicker. And I'll have to decide if I want to redo that or not. It's kind of tucked underneath there real nice. I got to go back to that fuse holder. And I didn't do it last time, but I'm going to put some shrink tubing on here. So think about this while I'm doing it. Make sure I'm doing the right thing here. Yeah, this looks good. I go through the fuse holder, and then I go to the switch. And this will go to the switch. One side will go to the switch, and one side will go to the primary. All right. Okay, so I'm getting ready to plug this in for the first time. This is a long time coming. I sure hope we get some success. Gotta get the fuse first. I've blown 4 fuses so far trying to get this going. So this meter should be connected to B+. I don't know what it's going to be. It might be upwards of 200 volts. All right, I already got a fuse in here. I guess I should probably check it to make sure it's good. Yep, still good. Okay, so I have this powered off. See if anything happens here. Don't hear anything. I see smoke. I don't smell anything. So it might be kind of high. I don't have any tubes installed, so when there's a load on it, maybe it will be a little bit lower than that. I'm gonna get set up here. I need to find out where measure my B+ and make sure I've got heater voltage where I'm supposed to have it, and go from there. This is, wow, this is really good, really a good sign. And you can see, well, I know I got heater voltage because my, let's see if you can see that. I got my light. My light is lit up in here for the power. So that's going to indicate that I've got B plus, or not B plus, but heaters, because this is in the heater circuit, that light bulb is. So very cool. I'm happy. All right, I picked up some new capacitors for the power supply on this because the B plus is too high for the capacitors I have. I put in some, I think 22 microfarad, 150 volt rated caps, and the B plus is, as you saw, was almost 300 volts. So those are not rated. The caps I put in here are not rated for that. So I'll go ahead and I'm gonna make sure these are discharged, and then I'm gonna take this apart and put in my new capacitors. Okay, I got my new capacitors put in. The other ones I had were 200. I tried hot gluing this in here, but it doesn't. This aluminum, it must just be too smooth. It doesn't want to stick. So I'm not going to worry about it too much. You can't go very far. So I guess I can plug this back in and see, make sure our B plus is still the way it's supposed to be. Okay, so I got my new caps in. I'm going to plug this in and see, make sure I'm getting my B plus out. It's looking pretty good. All right, I'm going to get set up. I want to measure plate voltages in the pins before I put the pins in. Make sure we're good with those. Okay, I got the tubes populated in here. I'm gonna see what the B plus is again with the tubes installed. Hopefully you can see that too. Okay, we should be getting heaters. We do, it looks like we do. So we got about 213 volts with the tubes in it. I don't know that I have anything really turned on here yet. I'll have to, now I got to get my instructions and see if I can figure out how to use this the right way and start testing it. I think I'll probably need an oscilloscope next to do that. Okay, one more thing I wanted to do on this before I put this all together is I've got new connectors here. These are BNC connectors. I'm not sure exactly what these are called, but it's kind of an old radio formatting. If you have a CB radio or something like that, they used these kind of connectors. I don't remember what they're called, but you can, I think you can buy cables with these, or you can buy a connector to go from this to BNC, or you can make your own, but why not just take these out and put in a BNC instead? So that's what I'm going to do. Okay, I'll do a little demonstration here. I wasn't able to get the AM portion of this to work, but what I was able to do is get some FM action out of this. So what I'm going to do, I'll show you what I was able to do here. So I'll pull up my handy dandy instructions. Alright, so this is FM band, and what it tells you to do is you turn on your radio. So I've got this little radio here, and I've got a Bluetooth speaker I'm just connecting into it. And I've got this set to 88 megahertz, which there's no station there. So what it has me do on here is I go to, I set this to F. So that's F. So that's 32 megacycles to 110 megacycles. And then I set the pointer, let's see, I got it, set the band. So I got to set this on band F to 80, about 88. So that's about right there, roughly. And then I turn the modulation switch to AF out. Okay, that's there. And then I connect an output cable to of the generator to the antenna terminals. And let's see, this, I think it said I have to use see, I don't remember which one it is, but I think it says I have to use the RF out. Yeah, so what I'm doing here is I'm laying this next to my radio. Okay, and if I adjust this, so you can hear a frequency now coming out of the speaker. So this is an FM modulated signal, so it's transmitting FM 88 megahertz FM signal, and it has a 400 hertz tone on it. So all it's doing is sending a sine wave, but you can see, so this is about at 88, so it's not off by too much. All right, so that's, I was going to show I have at least some success with this then. All right, I'll turn this off. It's kind of annoying. Whoops. Okay, so I looked through this and I cleaned it up. I cleaned up the contact points as much as I could, and I measured connection to make sure that I was seeing the connections I expected to see between each of these metal pads and each of the individual pads on each of the coils, and I'm happy with how that looks. So I'm going to put this back in and solder it back up again. All right, this is how this looks put back together again. These are the caps I replaced on it. There's one more floating around here somewhere. There's another Black Beauty that I replaced. This one measured 50 microfarad. There's two caps inside here. One measured 50, the other measured 50 as well. So those changed from 20 to 50. So, you know, and it's an old wax capacitor anyway, so it probably needs to come out. The Black Beauties measured fine, but you're kind of asking for it by leaving them in there. Especially if I start using this a lot, it's possible that they'll go bad, and I'll have problems in the future, and I'll have to come back in here. I'm hopeful I won't have to come back in here. I'm guessing I probably will. But here's I changed this capacitor out. That was one of these, I believe, and then up here I had two more. These two I replaced because of these, and then the one on the back I think I've showed you guys already. That's these two right here are the ones that I put. It's kind of ugly, but I've seen people actually put this inside on the other side, which maybe I should have done, but it's already so crowded in there. I didn't really want to move it. I think this is where the instructions have you put it. This one was sitting back here previously, and the wires would go in. So yeah, that's about it. I'm going to put the tubes in, put it in the case, put my strain relief on, and then I'm going to call this done. I'm going to do some testing, and these numbers were wrong. That's why I left it that I did it that way. But the tape is correct. This is wrong. I'll probably cross those out. So, and then there's the transformer. I'll bring it up for now. I might have it in the video already, and I apologize if I do. But this is the Hammond transformer that I put in to replace the other one that appears to be shorted and just wouldn't work. And this is overkill. You can order custom ones. I think I paid about $75 for this one, and it's made in Canada. You can order transformers like this from custom shops. I think one of them, I could have gotten this for $60, something similar to this, but I would have had to wait 8 weeks for it because it's custom. And then there was another, I think that was Paul Electronics, and then there was another outfit that had something like this as well, but I think they also wanted $75 for it, and it would have been a 2-week lead time. So I would have been waiting for it regardless of what I did, other than just buying the Hammond and being done with it. So that's the direction I went. I might keep my eyes out for another transformer that meets the bill, that's more of a stock one, that's small and isn't so overpowered. I mean, this works fine, but it's overpowered. It's over spec for what I need, and I'd rather save the money and maybe put this in a guitar amp or something that really needs a big transformer. All right, so I wanted to run through the costs of this project. So the Heathkit itself was about $45, and then you can see the price that I paid for the various other components. I didn't include costs of things that I bought that I ended up not using because they were a mistake on my part, like the extra transformer that I bought that only powers up the heaters. And then I did remove like the BNC connectors. I bought 6 of them, but I only used 2. So that's the only cost I included. And then for some of the capacitors, I marked it as like I can't read that quite, but so there were other capacitors. There were some film capacitors that I used, and I didn't include those because I bought a kit with like 400 capacitors in it, and I used like 3 of them out of that kit to replace those black beauties. So it's basically a negligible cost at that point. One other thing I did too is I looked on eBay to see what was out there for similar Heathkit IG 102s like that I bought. And I just looked at eBay, and there were different ones that that you assume they work, but I don't know that they were tested or not. So some of those I marked unknown because the description said it powers up, but whether or not somebody actually hooked it to anything and tested it, who knows. And then there was a couple there that there was a really nice one that I think the second one from the top, the guy who was selling it must have been a technician or something, and he completely redid it. He calibrated it, retubed it, or not retubed it, but put new caps in and everything. And he had some extra things that came with it, like he did the BNC connector conversion, and he had cables and your BNC cables and things with it. So it was really kind of a deluxe kit. So that would have been, cost-wise, that would have been probably the best deal of any of these. So instead of spending $150 to fix mine up, I would have been better off buying his. But what's the fun in doing that? I enjoyed putting it together on my own, and so that's what I did. One of the other things that might come up as a question is why I didn't just use the transformer from my phone a friend that had the right outputs, except it was a 12-volt heater AC output instead of 6 volts. I could have done that. I would have had to get like an LM317 voltage regulator and then put some additional components in there, like a resistor that will absorb quite a bit of heat, and maybe some capacitors and other things that would support the LM317. I thought about doing that. It may have been a little bit cheaper since the parts would not have been that expensive. I guess in the end I just decided I didn't want to mess around with it anymore. So I just used the transformer, from the Hammond transformer that I bought online, and just called it good. So, and that's an option in the future too. Maybe I will go ahead and put that little transformer in there and make that, put in the LM317 to knock the voltage down from, it would have been knock it down from 12 volts AC to 6 volts DC is what it would end up being going into the heaters, or 6.3 or something DC in that range. And the heaters are happy either running AC or DC. It doesn't matter. So there's more testing I'm going to do on the IG 103, 102, but this video is already getting really long, so I didn't want to put any more of that into this video. If you like and subscribe, you may see me using that unit in some of my other testing. I've got other radios and things that I want to test, calibrate, and repair. So I hope you will like and subscribe to this video and tell others about it. So until next time, thank you for watching The Lone Tinkerer.